Hi everyone, I'm Charlie. Welcome to the first NetMeetup Scotland. This should be a little intro done by James, who probably invited you here. Unfortunately, he's had to run off. His wife's unwell. He was here a minute ago, and then he's buggered off. So he gave me, Lewis gave me some slides to run through, so I'll do that quickly, and then I'm doing a talk, and then James was going to do a much more interesting talk, but he's not here, so we'll probably do that next time. We're probably going to do these once a month-ish, maybe. Depends on the kind of feedback and see what everyone thinks. But we thought that once a quarter might be too infrequent, people would forget, so we'll do it probably once a month. So what is NetMeetup Scotland? So I've had to explain this a few times when people say, where are you going tonight? I'm going to a networking thing. Yeah, a networking thing about networking, just to qualify that. So that's what it is. We're trying to grab as many people in Scotland. We kind of figured after some UK NOFs and some Links events and some other bits and pieces that actually a whole bunch of us were trekking down from Scotland to go to NetMeetup in England somewhere. Very occasionally they bring it up here, but more often than not they don't. A little thing like this worked really well in Manchester, so we basically copied it. And so anyone in Scotland, and we think there's quite a few people who might be interested to come to this, it's an open forum to come and geek out, do a talk or two, and then just chat and basically geek out with each other for an evening. So yeah, no stupid questions. You can't really... It's really hard to pitch the audience because we've got a bunch of really clever people here, and no offense, but I think there was like a sales guy who was kicking around earlier, so you never know. But nonetheless, no stupid questions, and you can get drunk if you want to, as long as you don't heckle. What it isn't, I mentioned sales guys. You're welcome to come if you're sales guys, but you're not allowed to give a sales pitch. Also, this isn't like some elitist thing where we can only have the CTOs of tech companies come along and have a sort of closed forum. Anyone at any level who's vaguely interested in networking come along. Also, it's not sponsored. You should note that despite James and I kind of being here, or James not being here, but James organizing it and me presenting or whatever else, this has nothing to do with CommsWorld. My presentation shows a whole bunch of things that's related to CommsWorld just because that's my day job, but this actually has nothing to do with CommsWorld. And just like UK NOF or any of these other meetups, there's a respect policy, so don't be a dick. Right, on to my talk. So again, apologies if I've got the level wrong here, because it's quite hard to gauge who's coming and what understanding they've got. But I've done this talk a few times at different kind of tech meetup type events, and that was quite non-technical, despite it being a tech meetup, because I discovered that a load of people who are in the tech industry have no idea how the internet works. And I've done it at sort of in-depth levels, various different parts of this at things like UK NOF. So this is supposed to be pitched somewhere in the middle. I may get lost in techie things. I hopefully won't get too many people too lost. And apologies if I'm boring you to death, because you know all of this. The NetMeetup logo is this kind of box from the IT crowd, because that was the whole kind of cliche joke about the internet and what it is. The internet is not a little black box. It's more like these things. Big buildings like the one on Rose Street. That's Rose Street Telephone Exchange. And if you're like me and a manhole spotter, you will notice various boxes on the floor that say different telcos' names. And that is actually more like the internet, not like that. So a lot of people find that hard to quantify because the internet is this kind of weird, ethereal thing where they can meet their friends and do all that sort of stuff, but it's absolutely nothing like that. It is, of course, bricks and mortar, cables in the ground, and lots of shiny laser beams. So just going to quickly rattle through the access technologies that are typically used. So this is a kind of BT style diagram. This is one of many ways to run a network. BT do it this way, but you'll also find that there are people like Virgin Media who have a cable network that looks something like one of them, but using slightly different technologies. You'll find other people using radio, so like the guys at Lothian Broadband who have a network that looks like some of that for so far and then uses radio beyond that. And you've got other networks that are of all sorts of different permutations using different technologies like this. But just settling on what most people know, which is the wired BT style network, you will have probably come across broadband in the days of ADSL, and that's more or less how most people think of it, where you might have had visibility of this distribution point on the pole at the end of your house or on the side of the wall of your office or whatever it might have been, and somewhere that went back to a telephone exchange, which you may or may not have noticed at some point. In the telephone exchange is an ADSL DSLAM, and that is a piece of equipment that's connected to the twisted copper wire and provides your ADSL service. The reality is that actually it's probably got one of these cabinets in the middle, and you will have seen them, they look like that. These things are quite handy because what you can do with that is stick another piece of equipment next to it. It's an injection point, and they're usually at the end of the road, so you can inside the cabinet, you've got the E side facing the exchange and the D side facing the DP or the customer. So what you can do is stick another cabinet next to it. Usually looks like that. Oops. No, that's the inside of it. There we go. And what that does is allows you to stick a DSLAM much closer to the customer. So you get that much shorter loop, and you're using VDSL technology instead of ADSL. And all the V stands for is very high data rate. Don't quite know how you can squeeze three words into one letter of an acronym, but nevertheless they try. And that allows you to inject the signal much closer. You'll notice on the diagram that it still, sorry, I'll go back. It still uses, there we go. No, I'm being an idiot. There we are. It still uses the copper wire back to the exchange, and that's because most people still buy a dial tone service on the line, and that is still provided by equipment in the exchange. There's no need for that to be closer to the house. Inside the cabinet, you've basically got these type A blocks here on the right hand side. That's where it's jumping the signal in and out of the old cabinet. And then from there, it goes into one of the line cards in this DSLAM. Normally each cabinet can do about 250 lines. So you find these days actually, having been in for a few years, you're now trying to place an order for fibre to the cabinet and you can't get it because it's full. And it's because they're not very big. They didn't think very far ahead, and I think everyone thought that we'd probably have fibre everywhere by now. So that signal is delivered to the cabinet. That little white box on the right-hand side, that's where the fibre comes in. Each cabinet has usually 1 or 2 gigabits per second of backhaul to the exchange, and then that's shared amongst the 250 odd users, each buying an 80 meg odd service, or up to 80 meg depending on your line rate. So that's VDSL. You've also got a new version of this, which is GPON. Originally, GPON was going to be put on the end of the pole to keep it even closer, but they had issues powering the equipment. They didn't want to have to run a power cable. If they were going to run a power cable, they may as well have run fibre to the house. So they decided to put these on the side of the existing VDSL cabinets and give people who were really, really, really close to the cabinet a much faster speed, which sort of helps about 5% of the people who can get VDSL, who is not everyone anyway, so it's kind of pointless. Arguably, that money should be spent on that. So red in this instance represents fibre, and that would have been more or less what you get from a fibre to the premises type service. The annoying thing about the industry in the UK especially is that everyone talks about having fibre. What they mean about is having fibre to the cabinet. They now have this problem with advertising when we're getting proper fibre into everyone's home. How do we explain to them that they're getting fibre when they already thought they had fibre? So Matt Hancock, who's the MP running DCMS, coined the phrase last year, full fibre. So that's kind of what the industry is now using. We are talking about full fiber deployments as opposed to just fiber deployments, which were actually not fiber deployments, they were copper deployments. So the way that that works is using a technology called GPON. James, who's not here, was going to do another talk this evening on GPON, which is super interesting stuff. And we were playing with it for a project that never went anywhere, but learned quite a lot along the way. And I think we will probably save up that talk for another NetMeetup because it's really interesting and very, very clever. And if you already know, excuse me, if you already know how networks work today, you understand ADSL and FTTC and all these sorts of things, the likelihood is you don't know how GPON works because you've not had it yet. So that would be very interesting, and we'll probably do that next time. The kit for that looks like that. It goes on the end of the pole or on the side of the building, and they just run a cable out and plug it in, and off you go. That splits the signal, so you're normally getting a gigabit split about 30 odd ways. So much lower contention than fiber to the cabinet. However, the throughput is much higher. You're getting potentially a gigabit. I think BT's initial offering is 330 meg. So a gig shared 32 ways, giving everyone a 300 meg service, is actually not great contention. But at the moment, because nobody really uses 300 meg, and even if you try to, you couldn't. With 4K TVs in your house and everything else on the boil all at the same time, you'll really struggle. So we'll be okay. GPON isn't just gigabit, although the G in GPON does stand for gigabit. There's iterations beyond that, 2.5 gig, 25 gig, 10 gig, you know, all these sorts of things coming along. So that's access technologies. What does that physically look like? Well, I've showed you some of the kit. The reality is the network looks something like that. So these are some photos I took yesterday. Actually, that one I took a while ago when we were digging up Edinburgh. That is the Leith telephone exchange that serves my house, and that is a BT manhole with a fibre joint in it. So this is, again, the physical thing. It's really boring when you're walking along the street and you see a box on the floor that says BT or City Fibre, as those ones do, or Fluency, or anything. They are really where all this stuff is happening. These really nondescript buildings, which are usually built in the 50s and look terrible, and you wish they would tear them down, that's where it all happens, or at least that's where it all happens at the local access layer. You then get into the data centers and everything else, and they start looking a bit more impressive, but when you're wandering around your town or your city, that's more or less what you're likely to see, and that is the internet. When you get inside a telephone exchange, you start seeing some interesting things. So I bet nobody's, well, maybe Neil, seen one of these before. This is the cable ingress point in the basement of a telephone exchange. So these cables are, some of the ones on the right, they're hundreds of years old. They're the big copper 1,000 pair cables that distribute out to the city. And on the left, we've got the new fiber cables that have been used. And they bring these things in on these massive big gantries and feed them up into the exchange building. And they, it's quite an impressive sight. On the right, you've got these old Victorian cables going up into the exchange. On the left, you've got these new fiber joints, which are terminating the external grade fiber into low smoke, zero halogen internal grade fiber to go upstairs. And various different operators, cables. Obviously, all the copper is BT, but all the fiber is of different providers. So we've got one or two cables there. There might be Virgin Media or Vodafone or all these other guys who have their own cables into the building, and they take space in the telephone exchange. And that's called LLU, local loop unbundling, where we might take a presence in an exchange and put our own kit there, use BT's copper or BT's fiber to reach the customers in that local area, and have a choice of different providers for backhaul and whatever else. The copper infrastructure in the exchange looks a bit like that. That's the MDF, main distribution frame. So rows and rows and rows of 100 pair blocks. And these are connected to different pieces of equipment in the exchange, and they're also connected to the lines that go back out to the customers. What they do is when you order a phone line service or a broadband service or whatever it might be, a guy gets up that ladder, solders or punch downs onto, depending on the age of the block, it'll either be solder or punch down or something like that. Solders onto the connectors that's connecting to the equipment. He then gets a plastic stick and runs it all the way down with some jumper wire to the location of the block that he's trying to tie it back to for the cable going outside the building, and likewise he will solder it or punch it down, making that connection, connecting the internal equipment on a very specific pair number to the external network on a very specific pair number. And that goes out to one of those cabinets with the E side, and an engineer will connect up the exchange on the E side to the D side, to wherever the customer is, and all the records should flow that information through so that at the end of the day you get a dial tone service in your house, or you get a broadband service coming from something at that exchange.
Except when there's not enough copper, not just plug-ins.
Yeah. So what does that kit look like? Again, there's our racks. These purple racks are typically the ones that they provide to guys like us. We can put whatever we want in there. You can't really see it very closely. In fact, I've got another one that I'll zoom in on.
Charlie, you can get fibre carrying terabits.
Yeah.
Why can't they replace all those wires with just one fibre?
They can, they won't. As simple as that. They think there's a lot of value in that copper. And there may be to a tink. You know, you could probably gain some value by giving it some tinks, or pay the tinks to come and uplift it. But unfortunately, BT don't attribute the value in their duct network, which is really where their value is, because you can put more cables in that. And instead they attribute the value to the copper that is already there. Anyone else, if you ask City Fibre or Virgin Media or any of these other people who spend a fortune building new networks because they don't have anything that's, you know, 100-year-old legacy that was given to them, they will tell you that the value is in the civils, the work involved in digging up the ground. And once you've got that, you can change the cables out and do whatever you want with it. BT, unfortunately, have a very fixed way of seeing it, and it's left them in the past. So this is how we bring fibre in. We've got all these patch panels where we terminate the cables going outside, and we choose to flood wire them into our equipment so that we don't have to send an engineer to the exchange every time we connect up a new customer. So each one of those connections is 1 or 10 gigabit direct point-to-point connection to a customer, just because we're a business ISP and we typically sell lease lines. So when you buy a lease line from us, it's normally plugged into a piece of kit like that, and more or less if you want to go from 1 gig to 10 gig, we swap out an SFP and you get a much faster speed. So that's the fibre side of our setup. I mean, other ISPs and other providers will look something like that. That's just the way that we do it. Copper side is a bit more structured in that we get these 100 pair blocks which feed down to the main frame downstairs, and we pre-wire them into our DSLAMs. So those DSLAMs at the top, they're not ADSL DSLAMs. In our case, because again, we're a business ISP, we use a technology called EFM. So those are specifically EFM DSLAMs, and each connector, each DSLAM in total does 40 pairs. So we can, if we filled all 200, we could get 5 of them in a stack and do 200 pairs of connectivity out to customers.
What's the difference between EFM and normal copper?
Well, it's all the same copper, but EFM uses 2 meg, or well, between 2 meg to 7 meg per pair, and bonds it together as an Ethernet service. So it's like a poor man's lease line, but gives you reliability that you'd expect from fibre, but not all of the speed. So for people who have difficulty getting fibre in or can't afford it, then EFM's good, and it serves us well because it's quicker to install copper than fibre.
What sort of limitations have you got? Distance on EFM?
Yeah, it is distance limited, so it slopes down quite quickly, and at short loops of, say, up to 500 meters from the exchange to a kilometer, you might get 5 to 7 meg per pair. Going beyond a kilometer, that starts to nosedive pretty quickly down to about 1.5 kilometers, 2 kilometers. You'll be getting 2 or 3 pairs, 2 or 3 meg per pair, and beyond that, it will just disappear altogether. Yeah. Yeah, it's a symmetric service as opposed to ADSL, which the A in ADSL stands for asymmetric. talking of ADSL, that is a slightly bigger setup. So those on the left, that's a picture of some more tie pair blocks. And those are a picture of BT's DSLAMs. So when you buy a service from BT or someone who wholesales their service from BT, that's typically the kit that it serves. Inside those racks, I probably could have poked inside, but I wasn't gonna. They're just the same sort of things. These big chassis-based switches with line cards in them that do 100 pairs each or something like that. Now, the reason that the tie pair blocks are different colors, you'll notice there's green ones and blue ones there, is because many people want to be able to take their landline service and broadband together. And the way that that works is that BT will present the landline service to the blue tie pair blocks. That should be then pushed into the equipment and then out of the equipment with the broadband service on it. So you're sort of multiplexing together the dial tone service and the broadband service and presenting it back on the green tie pair block that effectively routes back out the building to the customer. So when you buy, people think of buying an analog line and then adding broadband onto it. What you're actually doing is buying an analog line and pushing it through your ISP's equipment and back out again with the broadband service on. And then your ADSL filter in your house does that in reverse. So who does this? We call them tier 2 networks because they're not really kind of tier 1s are people who own cables in the ground. This is just from an access perspective. These are just some examples as well. So TalkTalk is probably the biggest tier 2 in the UK. They don't physically cable up, they don't dig up the streets themselves and connect everything up, but they do have a presence in more or less all the telephone exchanges in all the main towns and cities. And they use that to provide their own service. BT Wholesale is technically a tier 2, although they're part of BT, who's a tier 1. BT Wholesale's function is as a tier 2 provider because they consume services from Openreach and create their own broadband service. Openreach itself is not actually a network operator, it's just a cable operator. You then got people like Zen, us, Neil, we're kind of tier 2 access networks from a traditional perspective. Arguably, you've got people like Hubs and Lothian Broadband and other people who are of a similar ilk, but using different technologies. So they're using wireless and things like that. So not necessarily a tier 2 network in the traditional sense, but nonetheless, more or less the same thing. Tier 1s are guys that have cables in the ground, arguably. There's another definition of a tier 1 which refers to IP transit providers, global networks, and that is something altogether different and is dependent on who they peer and pay for connections for and things like that. So once you get beyond the access network, where do you go from there? So again, in our instance, just give you, that's one of our core routers. It sits in Pulson in South Gyle. It's a Juniper MX480. It's got a bunch of 10 gig connections that we connect up to the rest of the world and connect back into these telephone exchanges that we're in. That is sort of reasonable for our size of provider, but actually quite small as far as ISPs go. If you look at the core network, the core routers that like Lynx use, they are full kind of 7 foot tall, hundreds of thousands of pounds, if not millions of pounds a piece, huge packet forwarding engines. And that's all they do. They just forward packets. They're actually dumb. They're just very, very fast at being dumb. And that's what London Internet Exchange use, for example, for their core equipment. And they serve different functions. I mean, different ISPs will need different things depending on what they're doing. The reason that we use Juniper is just because we don't just provide internet services, we provide carrier, point-to-point, MPLS, things like that. And Juniper gives us all of that. Other networks don't need that, so they might use something different. But generally, the size and price is scaled on capacity and throughput and what you can do with it, not necessarily feature set.
What's the capacity of your router?
Good question. Well, it's got 5, 6 slots, and I think each line card can do 100 gig. So we could do 600 gigabits per second on something that size. That thing can do dozens or hundreds of terabits per second. I don't know what it is. It's a lot. So how do you hook up your core network? With backhaul. So in the UK, these are some of the providers of long distance networks, or LDNs. They were all typically built, not all of them, but most of them were typically built with some other piece of infrastructure. So level 3 was built back in the 80s as RAICAL, which was the railway network. It was the first version of Network Rail Telecom. They sold it off and then built another one for themselves. Level 3 still has that access, so despite the fact that everyone thinks that nobody sells networking services off the railways, they actually do. Level 3 have that. Zayo was built with Transco at the time, so that follows the route of the gas mains. So you'll find if you look at the maps, which I'll show you in a second, it just crosses farmers' fields like nobody's business. Normally, networks follow roads or power lines or whatever else, but the gas network was built with a wayleave to just cut straight through the countryside. So it goes a really weird and wonderful way, which is good because you want many different networks to have different routes. You don't want them to overlap. Sky, so they now own a network which was built again late 80s, early 2000s with British Waterways, and it went down the canals and things like that. Now many of these guys share, so where Sky don't have a network because there's no canals, they go in level 3's network. And where SSE, who have built their network on the power lines, where they don't have power lines, they go in Zayo's network. So there's a lot of sharing and overlapping of all these networks. They have agreements with each other to share. So actually, when you start looking at the maps, I'm sorry if you can't see that, but that is more or less, the red there represents the railway map of level 3. You'll notice that they've got a lot of density that feeds out into lots of towns and cities, but it more or less follows a sort of figure of 8 around the UK, which of course is a very similar figure of 8 to Zayo. And when you look at SSE, it looks very similar. And when you look at some of these other ones, they all follow a similar sort of path. And it's typically the path of the towns and cities that they pass through. In the case of the railways, that's because there's towns and cities that they pass through, and they just happen to be there by virtue of the population. The gas mains, again, the gas mains were designed to hit the towns that needed gas. Therefore, the fibre networks do the same. Power lines, same thing. So the infrastructure routes around the country, even if they were built in the main motorways, they're actually a really good analogue for where the infrastructure was needed.
Why do you think when the network's being built, why do they continually share or piggyback off another bit of infrastructure?
Because it's cheaper.
Right, okay. That's it, purely commercially driven.
Well, a lot of the times these things were built with a very insular kind of requirements. They needed to build a network so that they could get to A, B, and C. If someone else had already built there and they were commercially agreeable to let you use their network, so for example, Zayo already have the route between Edinburgh and London. If SSE needed to get in there, they could rent Zayo a little subduct.
Yeah,
it would save a lot of cost.
It's remarkable that it's always on the back of something else, given how valuable it is.
Yeah.
That it's always on the back of a railway or a sewer or a gas main. It's never like, actually, this is important enough to do its own thing.
Funnily enough, so guys like Vodafone, BT, Virgin Media, and actually City Fibre all have their networks more or less along the roads because they're the easiest place to dig up. Retrospectively, if you're not doing another infrastructure project, the roads are the easiest place where you can just get permission and go and dig. It's expensive, but you can do it. So the ones that I haven't mentioned there are the guys who have just done that. So Vodafone, City Fibre, all these guys, their long distance network followed the motorways, more or less. Or the road, the B road that follows the motorway because it's too expensive to dig up the motorway. That's Sky's, which goes along the canals.
Really long distance. If you had put a very long distance,
Yeah.
is it cheaper to go over land or now it's sea cheaper?
If you don't need to get to anywhere in between,
That's right.
sea is cheaper
Sea is cheaper.
by an order of magnitude. If you think it costs £100 a metre to dig up a road and you're going from London to Aberdeen, that's a very, very expensive project. Whereas it might cost you a few million quid to build a landing station in London and a landing station in Aberdeen. More or less the bit in the middle, once you get going, is a lot cheaper per metre. Your starting overhead is a lot higher, but actually the total cost of the project would be less.
Is that expensive?
Yes, they're very expensive because they have to have all the infrastructure that a data centre would. I mean, if you get lucky and you have a data centre on the coast, they tend not to be on the coast because they're bad places for data centres. But if you were lucky enough to get a solid piece of infrastructure on the coast, you'd be okay. and you can take it in there. It's not so much bringing it in. I'll show you the process for bringing in a subsea cable in a minute. It's very trivial, but where you plug it in is not. It has to have the optical equipment to drive hundreds of kilometers, and that stuff's really complicated. Speaking of driving fiber long distances, there's some DWM equipment. This is the stuff that we use from Transmode, now in Infinera. That's a Sienna 6500, which used to be Nortel, I think. And these things basically are wavelength division multiplexing. So give you multiple different colors of light down a single pair of fibers and allow you to split that up into multiple channels. Typically, so our system, normal system that you put in today, allows us to split it up to about 40 channels, and you could theoretically get 100 gig out of each of those channels. So we could run that at, what's that, 4 terabits per second. There you go. Sienna 6500, same sort of thing. These things are not actually very complicated at the optical level. In fact, an optical mux you could buy for 100 quid and it's really simple. The expensive stuff is in the optics that drive it. So the actual light, sending that laser at a very, very specific wavelength, all of that distance, that's the expensive stuff. So that is our kit. There's Nick, very happy boy, having just bought a whole load of it. That's our ring that we've just put in around the central belt, sitting on a bench, being tested. Those things on the top there, those are actually the muxes. They're tiny little cards that take a pair of fibers in and split it out many times beyond that. And that's really the clever bit, if you like, but the cheap bit. The boxes underneath it are the really expensive but kind of dumb bit. International, that's kind of what the world looks like. It's growing all the time. There are new cables going down Africa. There are new cables, currently another cable going across the Atlantic. There's all sorts of stuff happening in the Pacific. Very little happening in Scotland, unfortunately, although we're trying to change that. They are exactly the same as terrestrial networks, with the difference being that they drop an amplifier in every few hundred miles. Not even hundreds of miles, maybe 100 miles or something like that. So they run a power line with it as well to power the amplifiers along the way. In the early days when they did this, sharks used to get a kick off of the power. So they found all their amplifiers getting destroyed by sharks. These days they insulate them a bit better so that sharks don't get quite so turned on by them. So what do these look like? So there's this great talk, and I'll put a link to a TED talk. You might have seen it. It's a guy called Andrew Bloom who's basically written a book about this, and it's fascinating. And he tells this story about this guy. He got told when a cable landing was about to happen, got given a few days' notice, and he said, go here in Portugal and sit on the beach, and at 9 o'clock in the morning, this guy will pop out the water. And he did. And with him, he came with this little rope and brought it ashore and handed it to a bunch of locals who basically started pulling it off the boat. And they were throwing it off the boat with a bunch of boys on it so it would float, and dragged it in, attached it to a digger, started pulling a heavy cable. The guy gets back in the sea, starts detaching all the buoys and heading back towards the big boat. At which point, these guys start literally sawing into it. And this is this huge cable at this point because of all the insulation and everything else that's with it. Start sawing into it with sort of industrial level of precision. They then,
The hacksaw.
they then bury it with a big metal shroud in the beach so kids digging sandcastles don't get in the way of it, and terminate it in a manhole, at which point they then get on sort of jeweler's precision to start working with the optical fibers, which are the size of a human hair. And it's this great story that he tells about, you should really watch the talk. I've put a link to it at the end. It tells this great story about them starting with mechanical, very, diggers and hacksaws, and ending up with tiny, human hair-sized fibers connecting continents together. It's really cool. So, I've gone on for ages, and I'll come to an end now. So, more or less in summary, when people say my exchange doesn't have fiber, they don't have a clue what they're talking about. They are loads and loads of different fibre networks in the UK. Lots of them overlap, which is a bit of a shame, but also good. The last mile stuff, despite BT's best efforts, is being replaced with full fibre. And yeah, the backhaul is aging. So, you know, these guys who built it all in the 80s and 90s, no one's really building new backhaul networks. Probably should get some more investment there. And international backhaul, conversely, is moving at a pace, which is really exciting. New continents are getting connected. Just the other day when Puerto Rico was having difficulties, we identified that actually Puerto Rico could do with a bit of help, because after a number of hours, obviously the generator that serves the one landing site for international cables in Puerto Rico ran out of juice, and every single prefix on the internet routing table for Puerto Rico disappeared off the face of the planet. And that just identifies actually how important these landing sites and these international cables are. They don't have very many of them into a country like Puerto Rico. They should probably have more. Scotland, probably a similar situation. If we were cut off from England for whatever political reason, who knows what would happen?
Do we have any?
We have one to Iceland and arguably one to Norway through the North Sea oil rigs, which is pretty crap. It's low capacity, it's nowhere near big enough to take all of our traffic. Not that it needs to, but it's not really going to a sensible place. If we were being clever, we'd take one over to branching point on one of the American cables north of Ireland, or we'd take one to Amsterdam and plug into AM6 or one of these big internet exchanges in Europe. Even Germany would be better than Iceland. But yeah, it's something. So those are some references. I think we're going to try and put this online. So those will work as links. And that was me. Thank you very much. So this is a really awkward slide. So thanks, me. James should be doing this bit. The Beehive's quite a good venue, so we'll probably come back here. And thanks everyone for coming. Please hang around and have some beers and maybe eat some food and chat about networking. We'll be around for a few hours, yeah.